The derivatives of carboxylic acids can react with nitrogen nucleophiles. These are ammonia derivatives in order to get amides. We can get primary amides, secondary or tertiary based on the nitrogen nucleophile that we start with. So if we start with ammonia, we're going to get a primary amide. If you replace one hydrogen of the ammonia with an R group, then this is a primary amine. If you react the primary amine with any of the derivatives of carboxylic acid, then your product is a secondary amide. And then if you replace two hydrogens of the ammonia with two R groups, then you're going to end up getting a secondary amine. Take that secondary amine, react it with the derivatives of carboxylic acid, and you're going to get a tertiary amide. If we are reacting a tertiary amine in presence of a base and water, we will have no reaction. And the reason we will have no reaction, because each one of these nitrogen nucleophiles is losing a hydrogen in the process. So each one of them, you're losing a hydrogen in there. Tertiary amine has no hydrogen to lose. So you're not going to end up having any reaction in this case. So you're going to be losing a hydrogen and leaving a group of the derivative of the carboxylic acid. So your byproduct is going to be either an HCl if you start with an acid chloride, or a carboxylic acid if you start with an anhydride, or an alcohol if you start with an ester. Let's have an example in there. So starting with an acid chloride, the mechanism is going to proceed exactly the same with each one of these derivatives of carboxylic acid. Since I'm doing a basic medium, then I'm expecting the nucleophile immediately to attack the carbon of the carbonyl. So my first step here is that the nucleophile, this is a primary amine, will end up forming a secondary amide by losing a hydrogen from the nitrogen and the chlorine in there and combining everything together. Mechanism straightforward. Nucleophile attacks the partial positive carbon, forming a negative charge in there. And then resonance happens so that the leaving group is going to leave. That is going to be a Cl minus in the solution. Every time I'm using a Cl minus, remember when we said that with acid chlorides you need to use pyridine. Well, here I don't need to introduce another nitrogen base. I already have a nitrogen base in here. So the moment I form the HCl, then this nitrogen base is going to come and trap that acid. This is why over here we said that we are using excess of it. And the reason why we are using excess of it, just to make sure whenever we form the HCl, we have enough base in order to form the ammonium salt. Let's have another example now with esters. So let's say if we have this ester over here, and we are reacting this ester with a secondary amine. There you go. So I have a secondary amine. Remember that nitrogen has 3 bonds and a lone pair so that it's a neutral. This is a CH3. This is a propyl group, so I have 2 R's that are different for my amine. So here I'm reacting this with a secondary amine. Okay. Let's start with the mechanism of the reaction. Since it is a nitrogen base in there, so the medium is going to be a basic medium. And if it is a basic medium, then the nucleophile is going to immediately come, attack the carbon, and form a negative charge on the oxygen. So I'm going to form now the addition of that nucleophile. So I added the nitrogen, I added the hydrogen, and I added the 2 R groups in there. Now the nitrogen is a positive charge. I have my O negative, and I have my OCH3. Check the medium that you are working with. the medium is basic, this means that I can have the OCH3 as a good leaving group in basic medium because the oxygen here, it has lone pairs. And in basic medium, oxygen leaves in a form of a lone pair. You don't have to make it a plus charge to leave. You make it a plus charge in acidic medium. And I will form a carbonyl back, and then the auto groups on the nitrogen. And of course, I have a hydrogen over here with a positive charge on the nitrogen, plus whatever left, which is the OCH3 minus. Always look at the medium that you are working with. If I have a base in here and I have an acidic hydrogen in there, then immediately that base is going to come and take that acidic hydrogen. So this one is going to take the acidic hydrogen and form a lone pair on the nitrogen, which is going to be my product, my neutral amide product. So there's going to be a carbonyl, a nitrogen, this is the propyl group, this is the CH3, plus of course I have my byproduct, which is in this case the alcohol. Whenever you are working with esters, the OCH3 is going to leave. So what I did over here is that I lost the OCH3 from the ester, and I lost the hydrogen from the secondary amine, and I made my tertiary amide. So your product here is a tertiary amide. The reaction is going to proceed exactly the same whenever you have ammonia instead of the derivatives of ammonia. This is a basic medium, but you have to make sure that always your product is a base. So here in this case, I need to use excess of the ammonia, and the reason why, because at the end, if you lose a hydrogen from the NH3 and you lose this whole leaving a group over here, then you're going to get an acid, carboxylic acid. You cannot form an acid in basic medium, so this is why you would need to use another mole of the base to take the acidic hydrogen and create the salt. Let's go over the mechanism of the reaction. So you're going to start with the ammonia. The first mole of the ammonia attacks the carbon of the carbonyl, form a negative charge on the oxygen there. And then you're going to do resonance, and this whole thing is going to leave. It is a good leaving group because you're working with a basic medium, and oxygen can leave in a form of a lone pair with a basic medium. Now, once you form your carbonyl in there, then whatever left can come and pick up that extra hydrogen, and you are going to end up getting your amide in this case. Since I'm having an ammonia to be my nucleophile, then I'm going to end up getting a primary amide plus the acid. Follow always the medium that you're working with. If you have a basic medium, it doesn't make sense to get an acid as a byproduct. So now I'm going to use another mole of the ammonia to pick up this acidic hydrogen by an acid-base reaction, and I'm going to end up getting my salt in this case. And that is going to be the byproduct of the reaction.